Alright guys, today we are going to be looking at our first target in statistics. Right, and so statistics is simply the study of data, okay? And statistics is when we study that. So, anytime we're talking about statistics, we have what we call the population, which is all the members of what you're trying to study, and a sample, which is just a portion of what you're trying to study that you actually look at. So for example, if I want to know how many students in the high school have an I, right? So an incomplete. How many of the students at the high school have an incomplete? Okay. So my population for this is all the students in the high school. Okay. My sample then depends on what I take as my sample. Okay. And there's 4 different ways we can take a sample. The first one is a convenience sample. Right? So that's just selecting any members of the population who are currently and readily available. So that's if you ask all the kids in your class if they have an eye or not. So that's convenient. You don't have to really do anything extra. You're already going to class and you're just asking all those students. Okay? It's convenient to you. So then, in a convenience sample, our sample is just, while the population is still all the students in the high school, our sample is the students in your class. A self-selected sample. Okay? A self-selected sample would be something like you make an announcement. Make an announcement asking students to fill out an online survey, right? And the online survey would ask like questions like, do you have an eye in this class? Do you have an eye in this class? Blah, blah, blah. And you can see how many students have an eye, right? It's self-selected because, right, people have to volunteer. They have to go on the website and they have to answer the survey. It's only people who choose to do so. In a systematic sample, we order the population in some way and then select from it at regular intervals. For example, if I organize the school population by ID number, then choose every 10th student. Every 10th student. Okay? That's systematic, right? And just organizing and choosing. And then our last type is a random sample. All members of the population are equally likely to be chosen. So that would just be choosing. Sorry about that. Choosing 100 random students. Yeah, more than 1. Okay, so choosing 100 random students. And you can choose random students randomly in a number of ways. I can, there's computer programs where if I input all the names of my students, it'll just throw back 100 names at me randomly. There's random number generators. You can throw all the students' names in a hat and pull 100 students out of a hat, right? All of those are random ways to choose your students. When we're talking about our sampling method, we have to talk about bias, okay? A systematic error introduced by the sampling method. There is bias when part of a population is overrepresented or underrepresented. So when we're thinking about bias, we have to think about which part of our sample is overrepresented, right? So looking at our first one, right, our worst types of sampling, right, are convenience, that comes in third, and self-selected. Both of those come in third place. Okay. If I look at my convenience sample, right, well, I'm only choosing from students in my class. If what you're choosing from is not the same as your population, right, all the students in the high school, right, that's when you have bias. So I'm only choosing students from my class. And that could skew your data in lots of ways. Right? If you're an honors kid and if you're in all honors classes, and you only are asking other people in honors classes, well, students in honors classes are less likely to have an I, most likely. So that's going to change your data. Okay. Making an announcement, asking students to fill out an online survey, right? Again, only people who go online, right, or hear the announcement or whatever are going to be able to do that. And also, in the same way, right, students that actually fill out the survey, again, are the students who do things outside of class. They're more likely to not have an eye. Okay. Systematic sample, that's our second, that comes in second place. That's a pretty good way to choose it, especially if you organize the entire population, right? Here I am organizing the entire school population. So I am choosing from my whole population. So this one is pretty good and doesn't really have any bias. But sometimes, and we'll see an example of that, a systematic sample can have bias. And then our best way is a random sample. Random sample comes in first place. Right? A random sample is pretty much always no bias. There is never any bias for a random sample. So let's look at some examples of them. Okay. So for each situation, determine what is the sampling method used and what bias the sample has. So for example 1, a newspaper wants to find out what percent of the city population favors a property tax increase to raise money for local parks. So my population is everyone in the city. In the city. Everyone in the city is my population. Okay? So looking at a newspaper article on the tax increase invites readers to express their opinions on the newspaper's website. This is a self-selected sample. It's asking people, right, to go and do something, right? Only the people who choose to do that will be chosen, will be part of our sample. What's the bias here? Well, a newspaper article tells them to go do it. So this is only choosing from people who read the newspaper. Right? Only choosing from people who read the newspaper. Right? Not everyone in the city reads the newspaper, especially this specific newspaper. Right? So it really cuts down your population, and that's where you're choosing your sample from. So that's definitely a bias. For B, a reporter interviews people leaving the city's largest park. This is a convenience sample, right? He's just standing on the street talking to people, like, right? Just using people that walk by as they leave the park. And our bias for this one is it only choosing people who go to the park. Right? Again, not everyone in the whole city goes to the park, so it's not representative of your whole population. Especially for something like this, where it's asking about, right, property tax increases. Property tax increases to raise money for local parks, right? If you're at the park, you probably want more money for the park, right? Because you like the park. So in our next one, a survey called Every 50th Listing from the local phone book. Right? This is a systematic sample, right? You're listing them and choosing. Unlike our earlier example, this one does have bias because it's only choosing from people who are in the phone book, right? Not everyone is in the phone book. I know I'm not in the phone book. I don't have a home phone number, right? I only have a cell phone, so I couldn't possibly be chosen for this sample, right? There's no possible way. So that is bias. All right, let's look at our next example. All right, example 2 says a supermarket wants to find the percent of shoppers who use coupons. A manager interviews every shopper entering the greeting card item. So this, our population for this one is shoppers of the store. And this is a convenience sample. He is just standing there, waiting for people to walk by. And it only is choosing people buying greeting cards. Alright. And then B, a maintenance crew wants to estimate how many of 3,000 air filters in a 30-story office building need replacing. The crew examines 5 filters chosen at random on each floor of the building. That word random means this is a random sample. Okay? And then remember, a random sample always has no bias. Any of the air filters can be chosen. Okay? All right, looking at the next page. All right, once you have chosen how you're going to choose your sample, you then have to choose how you're going to get your information. So there's 3 ways, once you've chosen who you're going to look at, to then ask the questions or do the experiment or do whatever, get your information. And these are called your study methods. So let's say I've chosen my sample. Now, I want to figure out the question. What is the relationship between studying and test scores? So the first type we have is an observational study. You measure or observe members of a sample in such a way that they are not affected by the study. So in this case, I could look at the number of students who completed their review and their test scores. Okay. So in this example, I didn't actually ask them anything. I just went into my grade book and said, okay, these students completed their review, these students did not. This was their test scores, and kind of see some relationship, try and find a relationship between that. Okay? Didn't ask them anything. In a controlled experiment, you divide the sample into 2 groups. You impose a treatment on one group, but not on the other. So, for example, choose 10 students to study for an hour. And 10 students do not study. Right? So I have 10 students who I'm going to study. You have to study for 1 hour. And 10 students, you are not allowed to study at all. Then record their test scores. Right? So in this one, I told 10 students to do something, and 10 students, that's my control group, they're not going to do it. And then record their test scores and see how their test scores were different. Then finally, we have a survey. For a survey, right, I would just ask students how long they studied for. And what was their test score? So, and with a survey, I am actually asking these students that question, or a question. Huh? So remember, study methods and the way you sample are two completely different things. You can use any of the 4 study methods with any of the 3, you can use any of the 4 sampling methods with any of the 3 study methods. Okay, it's 2 different parts of your study. So let's look at some examples. Example 3, researchers randomly choose 2 groups from 10 volunteers over a period of 8 weeks. One group eats ice cream before going to sleep, and the other does not. Volunteers wearing monitoring devices while sleeping, and researchers record dream activity. This is a controlled experiment. I split my group up into 2 groups, right? I split my sample up into 2 groups, and then did one thing to one group and not to the other. Example 4, students in a science class measure the height of bean plants as they grow. Okay? This is an observational study. Sorry. Observational. That was all right. And I didn't ask the bean plants anything. I'm not splitting the bean plants up. I'm simply observing them. Example 5. Student council members ask every 10th student in the lunch line if they like the cafeteria food. Right? This is a survey. And this one's nice to see because it also shows you that, hey, we know there's sampling method too. If they ask every 10th student in the lunch line, that's a systematic, a type of systematic sampling, right? So they did a systematic sample, and then they did the survey. Okay? So again, it's 2 different things. I can use any of the sampling methods with any of these. And then my last one, a gardener tests can use plant food by planting seeds in the same package, in the same soil, and location. Each plant is given the same amount of water, but half of the plants are given food, and the other half are given no food at all. He records the growth and flowering rates of each plant. So this one, again, is split into 2 groups. So it is a controlled experiment. A lot of vocab today. It's a little bit long, but I will see you guys tomorrow. Have a great day.